Hi. These are other two examples of integral or integration, using the U substitution method. Okay, we're going to start right away. Um, with integral here, we can write a little bit different. So we can bring the root here up to the numerator. Okay, it's going to give us the integral. Right here, it's going to give us the integral of x times. Because this one here, let me just put it, it is like 1 minus 4 x to the power 2. It is equal to 1 minus 4 x to the power 2 to the power of 1 half. So when we bring it to the numerator, it gives us times 1. Excuse me. Just, okay. Let's do it. Okay. That one. Oh my God. Alright, now 1 minus 4 and x to the power of 2 and the whole thing to the power of minus 1 half and dx. Okay, now we can change the variable, by saying that u equals to 1 minus 4 x to the power of 2. Okay, and this actually means that its derivative will be minus 8x. Alright, and that also means that minus 1/8 of du equals to x. Okay, I'm doing this because I'm going to replace x, here by this value here. This one's going to go there. That's why. So now we're going to replace 1 minus 4x to the power of 2 by u in the integral and x by this other value. Okay, so that will give us u, that will give us x is that other value, but I can put it behind, it doesn't matter. So I'm first going to put u. We're going to have u to the power of minus 1 half times minus 1/8 d. Okay, I think that's all right. That is, it's all the same. So it is giving us here, I'm taking minus 1/8 out of the integral sign, okay, because it's a constant. And then I'm still having u minus 1 half d. Okay, so we will now integrate the whole thing. So that would give us that would be equals to minus 1/8, and integrating u to the power of minus 1 half. We adding, we increase the power by 1. So it's going to be minus 2 minus 1 half. Okay, so the new power will be 1 half, and 1 will divide the new power. Okay, and plus the constant of integration. Okay, and this is going to be then I have here minus 1/8. Okay, on one side, and here is 1 divided by 1 half. It means this is 2, or this is 2, and u to the power of 1 half, and u is 1 minus 4x to the power of 2, and the whole thing to the power of 1 half plus c. Okay, let me just check it if I got it. Okay, u is 1 minus 4 to the power of x to the power 2. That's correct. Then I can simplify here and give the final result. So that'll be to simplify here by 2. So it's going to give me minus 1/4. And then I'm going to have here 1 minus 4x to the power of 2 to the power, the whole thing to the power of 1 half plus the constant of integration. Okay, and this is here our first result of this other example. So now this second exercise or example is going to be a little tricky. So you know, just be careful when watching what I'm doing here. Okay, this function right here to integrate, we can also write it this way. We can say that it is a cosine of 3x, and it is also time the sine, 3x to the whole thing to the power of 10. This is what I mean. This is the same thing, okay? And dx. Okay, you see at the end why I'm doing it, which I'm doing it on purpose. Okay, now I can have I can have u equals to sine of 3x. Okay, I couldn't do that if it was 10 here. If I had 10 here, that's the okay. And its derivative means that its derivative du will be equals to will be equal to, and this one here is actually chain derivative. The chain, we use the chain rule here. When you have in the chain rule, you have u. Sorry, I had to start again. But then you have u times v x, to derivative. I might use another color, right? So again, I have a different color for that. Okay, when you have u of v of x to derivative, of course it is, first of all, you got to derive, the in, because it's a chain, rule. You have to derive this function in here, that gives you v prime. Then you derive the outer function, that will give you u prime, then times this function dx. Okay, so let us just apply to this function here to have the derivative. So it's going to give us here, we said, first of all, we're going to derive this one here. The derivative is 3 times the derivative of this other function out, and the derivative of sine is cosine times dx, and dx is 3x. So we got it here. Is that okay? So we got it. Okay, as you can see in this derivative here, we have a cosine of 3x, and this is the same thing we have here. All right. Oh, I forgot a dx here, because this is a derivative you have to apply. Excuse me, make some room there. Okay, you have to apply an x on it, dx. Okay, because this is a derivative. So, like I was saying, in this derivative here, we're having these. Just put it maybe a different color so you can see. Yeah, that one. We're having 3 and the cosine of 3f dx, and this is the same thing here, right? So if you just rearrange it, you just take this one to the top. Here in front, so it's going to be the same. Now we can write that. We can write changing, like dividing here by 3 in order to have this value isolated, right? Yeah, we can have this value isolated here. So it means that this one means that 1/3 of du equals to the cosine of 3x and dx. Okay, dx. Okay, now check this out. What do we have? We have cosine dx, so this is the value here. We can replace it there, and we have this, and we have u sine of 3x. This is value here, so we got everything. So we can just plug it back in the original function. So it's going to give us the integral of this value here. This whole thing here will be 1/3 of 1/3 du. Okay, so it gives me 1/3 du, of course, time u. This is u here times u to the power of 10. Okay, and I can rearrange it by, first of all, by taking 1/3 out of the integration. Integral sign out, and then put u to the power 10 du, right? Okay, now I just have to integrate u to the power 10. Okay, and of course I have 1/3 here, and u to the power 10, when we integrate it, the new power will be 11. So we got 1 u11, and the new power will be, I mean 1 will divide the new power plus the constant of integration. Okay, so that's gonna give us right here 1/33. Okay, and u, we're gonna replace, I mean plug by the value of u in here, and it is sine 3x. So we're gonna say it is sine 3x, okay, to the power of 11. We can see, we can, just like we did here, we can either put the power outside, I mean like this, or embedding the whole thing, or we can put it here just like we had it here at the beginning. So we're going to put it here the same, to the power 11 plus the constant of integration, and that's our result of this exercise. Okay, all right, well, thank you guys for watching again, and until next time, stay safe and see you alligator later, but not for a wild crocodile.